Okay, this is problem 10.3.5, and we want to simplify by factoring. And anytime we're trying to simplify a radical, what we want to do is write the radicand in its prime factored form. And the reason for that is that will tell us how many of each factor we have, and that's going to allow us to see how to simplify it. So to write things in their prime factored form, we're going to do a tree and start with any number that you can think of that is divisible into 162. And I see 2 being divisible, and it's 2 times 81 would give us 162. You could have started with 9 or 4 or anything that you wanted there. Actually, I guess 4 doesn't divide that, but 9 does. And then we keep breaking this down until we get to the point where we have prime factors. So this is an endpoint of a tree right here, of the tree, because 2 doesn't break down any further. And the 81 will break down into 9 and 9, and the 9s break down into 3 and 3. And those are endpoints of the tree as well, because 3s are prime numbers. So the prime factored form for 162 is actually 3 to the 4th times 2. Now, because I'm looking at a cube root, what I want to do is I'm going to rewrite this so I can see cubes, because when I get these to match, that's when I'm going to be able to pull these out. So I'm going to write that 3 to the 4th as 3 cubed. Then we'd have 1 3 left over and 1 2 left over. Okay, so see what I've done here. This is 3 to the 4th. This is also 3 to the 4th. I'm just splitting it up as a 3 cubed, and then a singular 3 and a singular 2. And the reason for that is when we have our exponent and our index matching, essentially it's going to reduce to be, that portion of it will reduce to be a 1. So this would come out as a 3, and we're left with the cube root of 3 times 2, which is 6. So that's actually the answer here. I'm going to write that a little bigger so you can see it. Okay, so now the rule that I'm using right there is this rule right here. When we have the nth root of x to the m, that's the same thing as x to the m over n in fractional exponent form. So just looking at the 3's there, if I had the cube root of 3 cubed, then this would convert into 3 to the 3 over 3. And that's where this reduces to be a 1, and that's why this comes out. And that's it for this problem.